Hi guys, we're going to be vodcasting the solutions to lab 1.4. My name is Ramsey Musalam, and I'm a member of blocks 2, 3, 5, and 6. I get to be in 4 AP chemistry blocks in the day. It's really exciting. In the pre-lab notes, we talked about the difference between a metal oxide and a non-metal oxide. In the lab, we looked at metal oxides, basically metals ionically connected to oxygen, and non-metal oxides were non-metals covalently bonded to oxygen. Woohoo! So, for problem number 2, cut it up to pieces. Why are you doing that? It increased the surface area of the magnesium. Do you think the reaction is exothermic or endothermic? Exothermic. And I would simply say it released heat. Okay? And we saw light. Heat and light are big symbols of exothermic reactions. Also, in order to do this, you burned it. Burned the magnesium. Burning something is a huge key that the reaction is exothermic. What is the algebraic sign on delta H? Whenever I say algebraic, I just mean is it plus or minus, and in this case, delta H is minus. Or you could say delta H is less than 0. Oftentimes, you are going to see it this way. So, you might want to get a habit of doing that. Let's write this reaction. Strips of magnesium are burned in air. Okay, so I wrote my reactants. I do not see ions, but I see 2 neutral atoms. So we're going to go up to 2 plus, we're going to go down to 2 minus, and we're going to stick. And we're going to balance, and there's the reaction. Other than synthesis, how could you categorize this reaction? Well, there's a down arrow and there's an up arrow. And when you see up and down arrows, you know that oxidation and reduction is happening, and we call that redox. Who is the oxidizing agent? Well, if the word agent is there, it's the person who's reduced, and the person that reduced is who went down, and that equals oxygen. It went from O2 to O2 minus. It's called a metal oxide. Why do you think it's called a metal oxide? Well, Mg is a metal, and that's oxygen. Very simple. Mg is an alkali metal, to be more specific. Should it turn pink here? Write and balance this reaction below. Okay, and this is key because you want to really use your keywords in your reaction trends, because when we write this, we have MgO and we have H2O. And this is why I really harped on this earlier. It's very important that you didn't put your 0 signs on the top of MgO or H2O, because they are not neutral atoms. They're neutral compounds. So when we look at this, we wrote our reactants. We do not see ions, and we do not see 2 neutral atoms. So we're going to go to the trends. And the key word here was water. We go on the other side, and we find that when metal oxides react with water, we have the metal connected to hydroxide in its soluble form. So on the trends sheet, it had sodium. We're going to replace that with magnesium, and we are good to go there. I believe that is all we need to balance it. Yeah, because there's the O here and the O here, and there's 2 O's there, 2 H's there, and our 2 H's there. So it's a balanced reaction. What was the key word? It was water. The other key words are going to be burned or combustion. You already know this one pretty well, actually. And heated. Does the product in number 14 validate your observations? Well, our product was our presence of hydroxide, and we did get a pink color. So, yes. When phenolphthalein turned pink, OH minus must have been produced according to the reaction. OH minus was produced. Holla for AP Chemistry times 10 to the 23rd. Smiley face equals AP Chemistry. Yay! Okay, so you should have had some mass, and the new mass should have been that mass minus some number, and basically the question was, do you predict what lose mass? Lose mass as H2O evaporates. The presence of that dot 7 H2Os mean that this compound has been soaked in water. It's what we would call a hydrate. And when you heat it, that water actually dissolves from the surface of it. Does your observation confirm this? It should have been yes. And here I would like you just to indicate your data. Okay. This answer should have been soluble, and according to solubility chart, SO4 2 minus plus Mg equals soluble. Okay, these ones don't match up on the chart. Good. So you can tell I'm very tired today, but hey, carpe diem, right? Confirm your answer by holding it under the electrode. Okay, so we had the light bulb turned on, thus the Epsom salt completed the circuit. Ions must have been present. At a few and draw a picture. They want to draw a picture of what happened to the Epsom salt. So I'm going to do that down here. So basically, you had your MgSO4 as a solid, you put it in the solution, and it broke up into its ions. And the presence of those ions is really what allowed the circuit to conduct. These plus and minus charges allowed the electrons that were needed to turn the battery on to flow through the solution. Add a few scoops of your Epsom salt into a test tube. Observations, you should have seen a white, cloudy, precipitate form. Okay, write and balance this reaction, cancel all spectators. So solution of sodium hydroxide, Na plus OH minus, is added to a solution of magnesium sulfate, Mg2 plus SO4 2 minus. Wrote my reactants, yes I see ions, no I see no neutral atoms, so I'm going to swap, I'm going to stick, I'm going to cancel out my spectators, and I'm going to put a 2 here, and I'm going to get MgOH2. So it's going to be 2OH minus plus Mg2 plus goes to MgOH2. Draw a picture of what this looks like in a centrifuge, where we're going to have the spectator ions up here, the Na plus and the SO4 2 minus, and down here you're going to have the precipitate, which is MgOH2. We can categorize this reaction as precipitation. Spectators are Na plus, SO4 2 minus, and I'll be back in a second to do the next video, guys. Got to do this in 2 parts. Take care.